Here we go. Troy won a toy car, and we're given one-dimensional, two-dimensional, and three-dimensional values. Okay, and as you keep reading, right, you see the word actual, like the actual car, right? So that means that the toy car is what we would consider the diagram, right? Would you agree with that? Right. So, no, sometimes you just have to read and see what makes more sense, right? So in this case, you could, if you would to use original, right, or actual, original and new, that works too. Just make sure you label properly, okay? So the scale factor used to 4 decimals, that's what we're after. And so we are given both of the volumes. So that's going to be how we're going to get our scale factor. So I know that both volumes provided. This is a three-dimensional value, so we're going to use knowing that the volumes of the between two similar shapes will be affected by a factor of k cubed. So I'm going to go volume of diagram, volume of actual. So k cubed is going to be volume of the diagram, which is the 125 centimeters cubed, and the other one is 1.55 meters cubed. Units are different, right? Convert 1.55 meters cubed. We know that 1 cubic meter has, oh, sorry, my bad. I was a little behind on the sliding up there. So we have meters cubed, and this is basically given to you up there in brackets, right? So you just do a quick conversion, and you end up with this, right? There you go. Centimeters cubed. So we need to convert this because a scale factor cannot have different units. So this is what we use instead. Does that make sense what I just did there? This is from over here. I did say it. If I did say it at the beginning, watch out, there's this little bracket here that you need to take into account. That's what I mean, read carefully, right? Sometimes it's too much information. Sometimes it's there for you to pay attention and make sure you read it carefully, okay? But it does happen. But I want you to not think that it's always going to be the same, all right? Not always going to be the same. Read carefully. So anyways, we got both units the same. So now we can cancel them. Perfect. That's what we want. Cube root, both sides. So k is just going to be, oops, I can actually do that in one shot, right? Math, cube root is right there. Close it, and you get that. And you can't get it into a, I'm pretty sure I tried, yeah, you can't get it into a fraction. So 0.432, I'm going to use 4 decimals because the question did ask for it, right? So that's a scale factor that has been used because look at it this perspective. The original, the actual has been reduced, right, to get that toy car. So is that reduction of the original, right? Okay. Any questions about this part? Okay. B, calculate the length of the actual car. We length, right? We're talking one dimensional. So we can just use K without squaring or cubing or anything like that. We'll just go length of diagram, length of actual. Got it? And do you know what the scale factor is? You just figured it out in A. So I'm just substituting there. 0.0432. What's the length of the diagram? It's 12.5 centimeters. And so length of actual is unknown. Okay. No squaring, no cubing, okay? Because we're dealing with length. So here you just cross multiply and divide. So if you cross multiply this way, it's length of actual multiplied by 0.0432. And there's a 1 here that multiplies at 12.5. Divide both sides by 0.0432. Okay, those cancel out. Length of actual is 289.35 centimeters. If it had asked you to state that in meters or yards, you go ahead and just convert that, right? But this is what we're after. Okay. So once you get the scale factor, you can use it for A, B, C, D, E, right? Like anything I asked thereafter, you can use the scale factor for it. Okay. And then C, calculate the surface area of the actual car. I think I'll be able to fit that in here. So C, surface area, we're thinking two-dimensional. So I always go back to this one, K squared, because areas means that the scale factor will be affected by a factor of K squared. So we know surface area of diagram over surface area of actual. And then you just plug in K squared is equal to surface area of the diagram, which I know is 48 centimeters squared. And surface area of actual, we're just going to call that X for now. It'll be quicker that way. So let's square that. You can square it right away, but don't round it, or just leave it like this. I have a feeling that most of you will not like that. I'm just going to go ahead and square this. I'm going to square that, and I get 0.001866624 is equal to 48 centimeters squared over X. I think I'm okay in introducing a shortcut here. So what I always do is, if you put a 1 underneath, you're not really changing anything. It's just a placeholder. And you cross multiply this way, and you divide going up. If this throws you off, just keep doing what you were doing before. So it's 48 times 1 divided by this. Okay? 48 times 1 divided by 0.00186624. So because your calculator has that number in there, I'm just going to go 48 divided by arrow up to select that last answer, copy it down, and then get my answer that way. 25,720.16, and we are in centimeters squared. is the surface area of actual car. So in terms of the little details of how you show your work, if you keep this like that squared and you work with that throughout, that's fine. Just don't drop decimals as you work because you have a calculator that can copy, right? Are we good with that? Yeah. Does it make sense? That, again, I will tell you this. If you get this right, you basically always go back to it's either K new original, right? Or it's K squared area of new area of original, or it's K cubed volume of new volume of original. And the same goes with diagram and actual. But if you know two of these, you can find the third, right? So if you always come back to these formulas, then you should be able to plug in and go. Make sure the units are the same, and then you'll be fine. D. I will just try to remember. If the width of the actual car is 1.8 meters, determine the width of the toy car. So is that, how many dimensions are we talking if it's width? One dimension. It's just a single dimension, right? So let's go ahead and at the back here, width should tell you that it's one dimensional. So I will use this. K is the width of diagram over width of actual. That's how I'm going to relate that. That's the one I'm going to use. I know what K is, which is 0.0432. Is it really that? Let me check. There, yeah, it is. We're good. I don't know what the width of the diagram is, but I do know what the actual width is, which is 1.8 meters. So I'm just going to put an X there for my unknown. And I'm going to introduce the shortcut again. I'm okay with it. If you have a different teacher next year, they might not like it. But you start on the side where your variable is and you go diagonally across, always multiplying first, and then divide by what's left over. In this case, it's 1. So X is really 1.8 times 0.0432 divided by 1, which is irrelevant. I'm going to just show it here as a placeholder. So it's 1.8 times 0.0432, and it's 0.07776. And what units am I in? Meters. Would this be a good way to state your final answer? I would be okay on a test. That'd be, technically, I didn't ask you, but we're going to convert it to centimeters, all right? Because it's just, it looks weird. So we're just going to go 1 meter as 100 centimeters. Cancel, cancel. So the decimal just shifts over 2 spots. So it's 7.78 centimeters if you round it. In case some of you are wondering, what did he just do? I just went times 100, and then I round my final answer here to 2 decimals. I would probably ask you on a test, state your final answer in centimeters, most likely. Yeah, most likely. Okay. So this question kind of does everything. First, the first thing you need to do, just like in a chart, find K, find the scale factor, and then you can find everything else about the two. You need to find out how are they related. It may require you to take the cube root. It may require you to take the square root. It may require you to just divide two numbers if it's one-dimensional. Question? Go ahead. Now I'm going to give you a table because I will guarantee you this, there will be a table on the test. Okay, I can tell you that much. So just take, okay, pay close attention so you can do this right. Leave three lines in between each cell. Okay, so write down the headings first. What I did there is I just used the width of my ruler to determine the width of the columns. That's what I did. Okay. So just write down, complete the table. And because you're not going to remember which one was there to begin with, I'm going to highlight the numbers that were in. Write this down. So the idea is that the one that's all filled in, we call that the original. So I don't know, I will not have that on a test, but you should know that that's the original. And we're making copies of that, okay? So the idea here is it could be any objects, it could be cones, spheres, cars, it doesn't matter. They're related. And so just make sure that, and for example, in this case, how did you get the volume? How did we get that volume if you only have length and width? Well, the height has been omitted, right? It's not included, so you don't quite have enough information to get like the volume of the copy that you're making here, other than the scale factor. And so the scale factor is always the first thing you need to find. In this case, it's provided. So I'm going to start from the left here. I'm going to say that the length of the new is simply taking the scale factor and just go length of original. That's a shortcut. If you use the formula that I gave you, you get this, okay? So for a chart, let's just be efficient. So it's 4 times 4 inches. So that's 16 inches, right? That's the answer that's supposed to be in that cell. So on the test, this chart will be somewhere in the page, and if you want to do the work around it, that's fine, as long as you clearly tell me where it's supposed to go, okay? And then so the width of the new is k times width of original. So it's 4 times the width of the original is 3 inches. So that's 12 inches right there. I'm going a little faster so we have enough time to finish this. Area, it's a little different. Area of the new shape will be k squared times the area of the original. Okay. So k squared, right? We take the scale factor we got and square it and multiply it by 12. That is 16 times 12. That's 192. 192 is the answer there, squared inches. That's what we're after. Volume, that's not just k, it's k cubed times volume of the original. So that's the pattern. Once you have your scale factor, it's just as easy as that. 4 cubed, 16 times 4, right? 4 cubed, bring it the cursor down, times 84. That's 5376 cubic inches. So this is what we're after here. So if you made a copy of the original that's 4 times larger, your volume would be 64 times larger, because 4 cubed, right? Remember prime factorization? Okay, pay close attention before I start copy 3. It's always based on the original, okay? Forget about the second copy, because a lot of students, they mix up numbers. So you almost want to block that for a bit and just focus on the original and the copy. You need to find scale factor first. In this case, the only way to do that is by relating their volumes. So I need to find, I'm going to go, k is the cube root of volume of new, volume of original. Cube root, make sure you indicate cube root, not square root. So the cube root of 0.1563 divided by 84. Math 4, I'm using brackets, 0.1563 divided by 84. You get 0.12. I sometimes use more decimals on my key. So if you look at my key later on, you're like, how come you use 3 or 4? I will not penalize you for doing that, okay? But 2 minimal. And now it's just, let's just, without writing down the formulas, it's just 0.12 times 4, right? And this is 0.12 times 3. And this is 0.12 squared times 12. And that's how you get your answers. This is 0.48. This is 0.36. this is 0.12 squared. Sorry. That's 0.1728 squared inches. And there you have it, right? It's the same thing over and over. Okay, I'm running out of time. So the fourth one, I'm going to record it once you leave. One more thing, question 9, you have to actually measure with a ruler on the textbook for you to be able to do that one. Okay, so I'll just finish this last one. Again, we need to find our scale factor. We're given both areas, so we need to find it by taking the square root of the areas, and it's always new. 8943. We're given 4 decimals, so we'll use them all. And 12 is the original. So we'll get that. Square root of 49.8943 divided by 12. And that gives you a scale factor of 9.789. I'll just write it all down. Okay, so that's scale factor. Now we're going to use that to find everything else in that row. So it's basically, you need to find a way, right? These two in this case will give you the scale factor, and then once you have that, you can just go ahead and fill in the rest. So this would be 9.789 multiplied by 4 inches, and then it's 9.789. Multiply that by 3 inches to get the width. So we'll get an answer here and here, and then we have to take the 9.789 cube it and multiply it by the original. And that's cubic inches. So in that sense, we'll get all of our answers. So 9.789 times 4. So that's 39.16. And I'll just copy that one and just change it to a, I'll just copy that previous line, change that to a 3. That's 29.37. And then I will also copy that one, delete, cube that times 84. And that is 78,794.20 cubic inches. So that's how you fill that in. And that concludes it. Make sure you try. In the booklet, there are the tables here. And the textbook is just a review of a lot of the things we have done. So just look them up there and you will be fine.